Alright guys, now we're going to go ahead and use the square root property in order to solve this. The first thing I want you to remember, the square root of 9. I'm looking for two numbers that could give me 9. Well, I know that the square root of 9 is going to be 3, and it's going to be negative 3. Oh, that's an ugly 3. That's a better looking 3. Alright, so it's going to be 3 and a negative 3. So essentially the square root of x, or square root of 9, is going to be plus or minus 3. Because negative 3 times negative 3 is 9, 3 times 3 is 9. Alright? Now, with this reminder, we're going to go ahead and we're going to use 2x squared minus 3 is equal to 0. So, first thing I'm going to recognize is that I can do this, I can think to myself, well geez, I do have an x, my bx where my b is 0, and realistically I can try to work that out, so on and so forth. But it's a lot easier just to go ahead, we're going to isolate this x. So I'm going to say plus 3, plus 3. This is a negative 3. I'm isolating the x, so I add 3, do the opposite. The 2 is multiplying, so I'm going to divide both sides by 2. Alright, now, in order to get this down to x, I'm going to take the square root of it. But notice what I do to one side, I still have to do the other side. So essentially, x is equal to the square root of 3 over 2. Now, here's the deal. I want you to recognize that this is the same thing as saying the square root of 3 over the square root of 2. If we remember going back to our rules on radicals. Now, it's bad manners to have a radical 2 in the denominator. We don't want irrational numbers, nor do we want imaginary numbers in our radicals. So in order to do this, I need to rationalize the denominator. And in order to rationalize my denominator, I'm going to multiply it by radical 2 over radical 2. Now I need you to understand, essentially what I'm doing right now is I'm multiplying in a manner to where I can get rid of my rational number at the bottom. However, I have to maintain the same balance, so I'm multiplying it in the form of 1, because radical 2 over radical 2 is 1. So I'm maintaining the integrity of the value of my radical 3/2, yet I'm going to make it look different in order to deal with my radical in the bottom. So x is going to be equal to radical 3 times radical 2, radical 6 over radical 2 times radical 2 is radical 4, and we know that x is going to be equal to plus or minus radical 6 over 2. Alright? Take a second. Make sure you understand, essentially, the big key here, we're working to isolate our x. We isolated our x. We took the square root of both sides. We went through, we recognized that the radical is written as such. We're going to go ahead and rationalize our denominator because of the irrational number of radical 2. Multiplying it by the form of 1. From here, and this really, honestly, this step's somewhat redundant. Normally I would just say radical 2 times radical 2, positive 2, but I put this in for your benefit. So take a second, go through this. If you like, put it on pause. If not, I'll give you a few seconds to make sure that you have this copied down correctly. While you're copying it down, I guess I'll tell a joke. So, an electron walks into, or excuse me, geez, I jacked up the joke already. Never mind, forget the joke. Alright, that's good enough. I'll have the joke for you next time. All right, 3x squared plus 27 is equal to 0. So I want to isolate my x. Positive 27, so I subtract 27 from both sides. 3x squared is equal to negative 27. 3 is multiplying the x squared, so I'm going to divide both sides by 3. X squared is going to be equal to negative 9. From here, I'm going to take the square root. Once again, what I do to one side, I have to do to the other side. X is going to be equal to plus or minus the square root of negative 9. Notice my negative 9, square root inside the negative is going to give me an imaginary number. So I'm going to pull out the I. From here, I know that the square root of 9 is going to be my plus or minus 3. So, once again, we're using subtraction or addition, in our case subtraction, followed by, in our case, division in order to isolate the x. To get it down to x, we're going to use the square root property, recognizing that we have a negative 9 here, so we're using an imaginary number. We pull out the I to designate the imaginary number, and the square root of 9 is 3. Take a second, enjoy that, put it on pause, whatever it is that you want to do. Assistant, you got any jokes? No jokes?
I can swallow fish without an eye.
Yay! Alright guys, here's the deal. X is inside and is basically being protected by this square. Alright, so I can't move this 1/2 over right now because it's being squared. Technically this is going to be x squared plus x, right, plus 1/4. If I really wanted to FOIL that out. I don't want to do that. I don't want to mess around with FOIL. I don't want to jack with that. It's already in a situation to where we can go ahead and we can just go right into it and take the square root from both sides. So when I do this, I get x plus 1/2 is equal to plus or minus the square root of 5 over the square root of 4. Notice the square root of 4 is 2. I keep my square root of 5, and now I'm still trying to isolate this. So I'm going to subtract this 1/2, and I'm going to do it from both sides. And that's going to give me x is equal to negative 1/2 plus or minus radical 5 over 2. Now I want you to recognize something. I have common denominators. So I'm going to be able to put them together. If I didn't, I can find common denominators and work them in should I choose to. Personally, me, I'm acceptable with this answer. However, if you want to make it a little prettier, right here. Essentially, these are the same thing. This is more in the form of a quadratic equation, which you'll be coming to see quite soon. But this form itself has its uses as well. Both of these, as far as I'm concerned, are good to go. But, you know, your teacher might like you putting it in this way. So, with that said, take a second and, you know, check it out. Notice that we went straight for the square root because, essentially, we couldn't do anything with this 1/2 until the square was taken care of. So we took the square root, brought it over, and then in the end just put it together with a common denominator. So that said, that's pretty much using the square root method. in order to solve for x. I hope you like it, and that'll be the end of this session. See you another time.